Good morning. Today is Thursday, October 21st. Today is Thursday, October 21st. And this video is for plate motion lessons 2.3 and 2.4. So this video is for just kind of a recap of what we did on Wednesday and Thursday. Since they were short days, I kind of combined activities and just pulled out of Amplify what was really most important for us to learn. So let me just recap what we did in class. First of all, we did the 2.3 warm-up, where we're really focusing on which one of those plate boundaries is between South America and Africa plate. So is it a convergent plate boundary or is it a divergent plate boundary? And so what we did is we did a second reading of Listening to Earth. And in this one, again, remember, we're still considering this investigation question. What happens to the plates and the mantle at plate boundaries? So we took a section, just one paragraph on the second page underneath the subheading Convergent Plate Boundaries. And we looked specifically at information that we could use to answer these three questions. So we're going to compare and contrast convergent plate boundaries with divergent plate boundaries. And the guiding questions are, number one, how do plates move at each type of plate boundary? How do the plates and the mantles interact at each type of plate boundary? And what landforms are commonly found at or near each type of plate boundary? So go to page number 2 of your article, Listening to Earth. Look at the second paragraph underneath the convergent plate boundaries. That paragraph starts with the sentence, at convergent boundaries, two plates are moving towards each other. Okay, I want you just to reread that paragraph and remember these three questions. Pull out or underline, write in your margins the answers to these three questions. I'm going to let you do that real quick and then start the video when you're finished. Okay, so you've finished going back through that paragraph for convergent plate boundaries. Now look at the very first paragraph under the heading for divergent plate boundaries. And it starts with Bob Ziak and his team don't just listen to the ocean near convergent plate boundaries. If you found that paragraph, I'm going to have you skim through this and I'm going to ask you to find the answers to those three questions again. So I'm going to go back to that screen that had the three questions. We're trying to find out now, how do plates move at divergent plate boundaries? How do the plates and the mantle interact? And what landforms are commonly found at divergent plate boundaries? Go ahead and pause the video while you do that. Okay, so now we know the differences between convergent and divergent plate boundaries. You probably saw a couple different vocabulary words. A mid-ocean ridge is an underwater mountain range formed when two plates move apart. So the plates that move apart, those are divergent plate, that's a divergent plate boundary. So a mid-ocean ridge is a mountain range. Sometimes there's volcanoes in those mountains, and they only form at divergent plate boundaries. And then the other word that we saw today was trench. And this is a long, deep indentation in the ocean floor formed when two plates move together. And the plates that move together are found at convergent plate boundaries. So a trench is found only at convergent plate boundaries. So then I want you to hand in your annotations. I'm going to check to make sure that you're making an effort to do those annotations. I'll pause the video while you do that. Okay, so you've handed in your annotations. We went ahead and jumped to activity 2.4. So we're in chapter 2, lesson 4, and then jump to activity number 3. We're skipping 1 and 2 today. And we're going to use the sim to continue exploring the plate boundaries so that we can make more comparison and contrast comparisons. So we can compare and contrast. Okay, so as student geologists, you carefully read Listening to Earth to find out what happens to the plates and mantle at plate boundaries. Now you're going to use a digital model, the plate motion sim. And we're actually going to do 2 parts in the sim. In the first part, you're going to create two different scenarios. So if you're on activity number 3, screen number 1, look at the top right of this slide. This shows you where you're at. Activity 3, screen number 1. There's 2 steps to this part. The first step, you're going to create a scenario in which rock is being added to the edges. Now, we're not telling you what plate boundary to use. This is where we're trying to kind of test to make sure that you know what plate boundary is the one where rock is being added to both plates. So follow the directions on there for the first step. I think the very first thing you have to do is make a hypothesis. So it's just a toggle. You just select what you think is going to happen. So do that first, and then follow the directions for the first scenario, and then follow the directions for the second scenario, in which you create a scenario in which one plate sinks into the mantle. Okay, when you're finished with that, then go ahead and fill out all the questions. It's just, again, a toggle down, select your answers for screen number 1. Pause this video, come back when you're finished. Okay, so I'm hoping that you found in part 1 of the sim that in order for the rock to be added to the edges of the plate, that happened during a divergent plate boundary, and a scenario in which one plate sinks underneath the other, that occurs during convergent plate boundaries. So I hope that you saw that in your sim. We're going to do part 2 of the sim now. We're going to use what we've learned about plate boundaries to identify and explain the interactions between the South American plate and the African plate. So for a second here, take a look at South America. That's right there on the left, and then Africa's on the right. We're talking about the plate boundary that goes right between the two. So you can see it's really, really long. We're trying to decide what type of plate boundary, that long one right between the two continents, what is that? What is that, a convergent plate boundary, or is that a divergent plate boundary? And so to identify what's happening at a particular plate boundary, we can look for general patterns. Remember, pattern was one of our vocab words, at plate boundaries on Earth, and see if those patterns match the ones at the boundary between the South American plate and the African plate. So once you set up your plate boundary type in the sim, you're going to want to turn on the toggles at the top to observe whether earthquakes and volcanoes occur at this plate boundary. We read about it in the article. Now let's see if we can model it in the sim. So go ahead and complete activity part 2. So look at the top right on this slide. You are in activity 3. Go to screen number 2. And it's going to give you a whole set of directions, number 1 through 6. You're going to do that for a plate boundary that is set for divergent. Once you let that run and you've got your information, look at number 7. It says repeat your observations with a convergent plate boundary. Don't do anything with number 8 yet. I'm going to tell you about that in a minute, okay? Go ahead and complete this part 2 of the sim. Pause the video and come back when you're finished. All right, so hopefully from part 2, you observed that at divergent plate boundaries and convergent plate boundaries, we were able to see both earthquakes and volcanoes, volcanic activity, right? What was interesting, though, is where those volcanoes were found. So at divergent plate boundaries, you saw that the volcanoes were occurring directly on the lime green line, which is the plate boundary. Whereas with convergent boundaries, you saw that they were happening near. They were not happening at the plate boundary, which totally makes sense because divergent plate boundaries, they form mountains and volcanoes. So it makes sense that the volcanic activity is occurring exactly right there on the plate boundary. Convergent plate boundaries, the volcanoes are occurring off to the side, which makes sense because at the convergent plate boundary, the landform that's formed is a trench. And so there wouldn't be a volcanic mountain there, it's a trench. So hopefully what you saw in the model kind of reiterates or reinforces what you learned in the article. And what I would like you guys to do is just let's review these two vocab words that are coming, or I guess just one vocab word. It's volcanic activity. Now, a lot of times we think volcanic activity means an eruption, and that is not always the case. It is any of the many processes, such as an eruption and lava flow, but it also could be gas, it could be an emission of ashes. It's any activity in which gas, lava, and ash are pushed out on the surface of Earth. Okay, this is in Quizlet already. You guys should be studying your Quizlets 10 minutes every single day so that you are learning your vocabulary and you're learning your key concepts. Speaking of key concepts, I have 2 key concepts for you today. So go to Good Notes. We're at key concept number 6. And we're going to just have a key concept for each of the different plate boundaries. So the first one is number 6. At divergent plate boundaries, rock rises from the mantle and hardens, adding new solid rock to the edges of both plates. And I had the kids draw a little model, I guess. What does that look like to you? So you would have, a little mountain kind of with 2 plates coming off to the side. I'll show you guys when you get back. Go ahead and copy down number 6. At divergent plate boundaries, rock rises from the mantle and hardens, adding new solid rock to the edges of both plates. When you're finished, go ahead and start the video again. Okay, the last key concept for today is key concept number 7. At convergent plate boundaries, one plate moves underneath the other plate and sinks into the mantle. Go ahead and pause the video and get that one written down. Okay, lastly, today we had homework over the weekend. Some of the kids got it done in class, some of the kids did not. So the homework is a compare and contrast plate boundaries graphic organizer. This is, I have a paper copy here, but I will also have a copy for you in Schoology. And this is just a graphic organizer in which you can compare and contrast divergent plate boundaries and convergent plate boundaries. So you're going to use the evidence that you found from your article, Listening to Earth, and the models that we created in the simulation so that you can write down the information to compare and contrast convergent plate boundaries and divergent plate boundaries. How are they similar? How are they different? Okay, this is due in class on Monday at the beginning of class. We're going to go over this together, and then I am going to take a grade on it. All right, as always, let me know if you have any questions. Talk to you later.